you guys have any questions. So, number 4, we're just talking about parallel lines. I'm guessing you guys have the question, right? Did it have something to do with same slope? Awkward silence. Okay, maybe not. Same slope, right? Number 4?
Yeah, same slope.
Cool. If some of you guys couldn't answer that question, here's the reason why. You're not taking my writing directions, like summarizing directions and problems, seriously. If you have no words written for number 4 besides parallel, I could take off a little bit of points and say you're not fully following the directions of writing summaries of the directions and the problems. Why? You should at least have a couple words as to what's going on in number 4. You don't have to have the whole sentence. You don't have to have every single comma and word, but you should at least have a few words. Otherwise, what did you just answer? I don't know, but it was parallel. What if you put perpendicular? I don't know, but I'm wrong. Well, good. That's not good. Just a little baby summary, okay? I'm only saying that because I started grading you guys last night. And when I started grading you guys, yeah. I think it was homework 2 and homework 3. Some people weren't writing anything for the vocab. Sorry, moving on. Number 10, matches with L2 is A, B is L1, C is L3. Number 56, let me give you just a second on that to check. I heard a Does that mean the problem looks weird or wrong? Okay, feel free to let me know because there were a couple typos in the last one. But I think this one's okay. If you guys notice, they went a little bit above and beyond, just like a quick teacher thing, just to see how my brain works. Do you see how they did the slope formula in point slope form? Yeah. Y2 minus y1 over x2 minus x1. Almost no student ever would actually think of doing that, unless they went to Calc Chat on like number 55 and saw it like, oh, I can do that. Almost every student, Algebra 2, Precalc, Algebra 1, would have done the m off to the side and then plugged it in. Just kind of giving you a heads up that you need to not just copy down what Calc Chat does, because it's not always smart. Like, there's a lot of math going on all at once. If you were to do m off to the side, make sure you have it right, then plug it in. Just a little bit safer to sometimes split up the problem in multiple parts. I'm not saying you're wrong if you did it like them. Just very few students would ever think of actually doing it like that. Oh, is that the last one? Go team. There are only like 3 evens, huh? Okay, I have the book open in case we have any questions, but you guys go ahead and let me know. Do we have anything on the odds from last night that you already knew you were stuck on, or from the evens just now that we graded? Yeah, go ahead, Joe. Jack. Joe. Wow, I said it right, and then I said it wrong, and then I said it. Go ahead, bud. 73B. Is there anything else before 73? Yeah, Taylor. 51. Okay, 51, 73. Anything else? Odds or evens? 91. Okay, so let's go ahead and start with 51. Oh. I got it, Jordan. Just give me a sec. Okay, you guys just checking out. I mean, Tyler, you could say it too, but I think everyone can probably fill in. Why do you think 51 is a little bit messy? What's weird or different about them? Yeah, M is undefined, which is why yesterday, Friday, in our notes, we actually took a little bit of notes on this very one, because we were like, special slopes, they're going to be tricky. So I'm admitting right now it's tricky. I totally get that. It's even trickier than m equals 0, because if m equals 0, just quick recap, if m equals 0, what kind of line is that? Right? You can ski that. It's just boring. It's horizontal. Horizontal, y equals 0x plus, they would have to give you something else. So say they gave you the point something like, because I don't think I see any m equals 0, do you? No. So what if it was something like -2, 1? Well, we have to put something in, right? Yeah, it's going to be +1, not because this is an intercept, because it's not. So maybe that's a dangerous way of writing it. Maybe I should have used point slope form. But we could have done y minus 1 equals 0 times x. Whatever's going on doesn't matter, because what's 0 times anything? 0. So we have y minus 1 equals 0. Okay. If m equals 0, Horizontal lines, always y equals a constant. So help me out. What's going on if m is undefined, which is much harder? It's going to be a vertical line. And vertical lines also have a special equation, but instead of being y equals a constant, vertical lines are x equals a constant. Well, who's x going to equal? Check out this one. The horizontal, we ended up stealing the y coordinate. Vertical, we're going to end up stealing the... So it's weird because we can't even plug it into any of the forms, because all of the forms are dependent on, well, actually we could plug it in. But would you understand? We have a little bit of time. If you want to see where it comes from, because I know some of you, you're like, we always plug in, we always plug in, we always plug in. We can't? You can. If it's a vertical line, where are we going? 6, negative 1. 1, 2, 3, 4, 5, 6, negative 1. What's another point on this vertical line besides 6, negative 1? Sure, 6, 0, right? We could do 6, 0, we could do 6, 1, we could do 6, 3, we could do 6 sorts of things. All these infinitely many points, the y's change, but the x's stay the same. What if we were to do the slope formula? So we could do y plus 1, y minus negative 1, equals m times x minus x1. Let's say we did it the calc chat way, which is super awkward. It's not my favorite. It's probably not at all how you learned earlier. But let's say we did it the calc chat way and we did the slope formula, all in the point slope form. Okay, slope formula. Who goes on top? y2 all over. You guys see where the problem is, right? Because all of the points on the line are going to have the exact same x, so it's going to be number over 0. But check it out. That would lead us to, let me scroll down a little bit, y plus 1 is equal to negative 1 over 0. I know it's weird, but it's right. Even though this is undefined, and even though y equals is not possible because of the slope of a vertical line, there is a little bit of a trick as to how you can still use this form. What if you were to multiply both sides by 0? What's 0 times anything?
0.
Distribute the negative. Negative x equals negative 6, so positive x equals?
Positive 6.
The weird thing is you can actually plug it into the formula, but a lot of people are just like, m is undefined, or they do this off to the side, m is undefined, it's impossible. Well, undefined actually has a fraction that it comes from, and you can actually see why x must equal. Or you could just memorize it, Tyler. So either way works. But it is kind of cool. You can actually use the formula to help you get there too. It's not like magical math where it's just like, oh, somebody saw undefined and decided to do something about it and like, oh, well, everyone has to memorize it from here on out. It's not quite like that. Number 73. Just trying to give you guys a little bit of a peek that in math sometimes it seems like things just kind of magically happen. You're like, that makes no sense. Okay, fine, I'll just memorize it. But there's always a reason behind it. Sometimes it's just a little bit harder to get there. Joe, it was just 73b? Okay. Before we can deal with parallel or perpendicular, we have to think about what we've been given. And we were given a point, and we were given a...
Non-standard form.
Well, actually, that is standard form, but it's not the one you like. What's the name of the one that you guys like? Slope-intercept form. Slope-intercept form takes this and does what? Right, because this form right now is ax plus by is c. The question is, where's m? Okay, but if we could just get it to be... Okay, so to get y by itself? Because it's not just y yet, it's still negative 2y. But if you divide everything by negative 2, are we okay with that? Because we could multiply it by a negative 1/2. We have to get rid of the negative and the 2. The negative turns into a positive, and this guy whoosh, whoosh, Just double checking positive 2x minus 3 halves. All of that work was just to figure out the slope of the other line. We're supposed to be making from this line another line that's perpendicular to. So when we start, oops, I left the space in the totally wrong spot. The m is supposed to be right before the x, right? Minus 2? Has anybody else, like, just because they were going fast, mistakenly replaced or switched the x and the y at all? No? It happens. For m, we just take the 2. And Jordan, you're right. It is 1/2. But what else do we have to do? Negative 1/2. Opposite, so it's a negative, not positive. Reciprocal. That would be for perpendicular. Now, is this totally done? No, because if you guys checked the answer, it would have been simplified, right? So I'm going to go pretty quick, but if you distribute, not killing a seal, negative 1/2 times x. If you're wondering, killing a seal is by doing a distribution error. You have to be careful. Negative times a negative is a and 1. So then you add 1 to the other side. Joe, is that good? Cool. Oh, we have 2 Joes. That's funny. Okay. And then last but not least, help me out, Wesley. It was 91? Cool. I'm surprised I only got 1 question on 91, unless you guys went poking around and you're like, maybe Calc Chat makes sense. Because this one was weird. There's no way you would have written this entire paragraph, right? Cool. So shorten it, summarize it for me. What was most important going into the problem? Because if you just went here, you'd be like, deer in the headlights, no clue what's going on. From 2013, 5 years. Kind of. I wouldn't say from 2013, just be careful. Remember the calculator worksheet number 2? 1980 was year 0. Remember that one? 2013 isn't year 0. That's why I'd be a little careful on that. But I would say 2013, from 2013, t equals 13. Value of a product is going to change in the next 5 years. What was the direction? What were you supposed to do? That gives the dollar value V in terms of year t. Here's what you guys had to figure out from that. So write an equation of a line. You're like, sweet, y equals mx plus b. No. What form do I want you to use?
Point slope.
Good. Point slope. Y minus y1 equals. Okay, this wouldn't be a big deal, except who's y? Who's x? Yeah, you have to take that from the problem. So it says value v of the product in terms of the year t. Now, we haven't talked about it. We will in section 1.4 in terms of, some of you might remember from algebra 2, function of, like f of x. Except in this one, we're not doing f of x because we're not doing y's and x's. Instead, what we're doing is v of t, value as a function of time. Or if you want to think about it, calculator worksheet number 2 again. Out of all those lists, what was almost always the x? Time. I mean, y was different stuff. Like, what was it? Like the pounds of the kid or the value of population. I don't remember what all the ones were. But time was always the x. So here's the dealio. Instead of the y, you're going to do a v for value. Minus v1 equals, well, we'll get back to m, and then t minus t1. Okay? Not that you had to write that, but that does kind of hopefully help your mind be like, oh, so we're not dealing with y's and x's, we're dealing with v's and t's. So now look at what they've given you. 2013 value is $2,540. Yeah. So what's t going to be if you have 2013? They gave it to you. So you can go ahead and plug in and say, okay, time is 13 years. From, I'm guessing T0 is 2000, right? So time is 13 years. We'll get back to M. But then the value, when It's 2013. It's just exactly what they gave us. So this was a hidden point. Here's your point right here. So if that's your hidden point, what do you think this is? Yeah, I was looking for the easy way of saying it. There's the slope. If you want to know why it's slope, isn't slope rise over run? Change in y over change in x. Wouldn't that be change in v over change in t? And wouldn't change in v be measured in dollars? And wouldn't change in t be measured in years? They gave you. When they said dollars per year, they gave you the slope. So m is equal to, now hold on, pause, decrease. Yeah, we're going to say the value is changing by $125, going down $125 per year. Or if you want to think about it, a more mathematical way of thinking about it, I suppose. It's confused as to what I'm doing, but I think it figured it out. Okay. Would have been negative $125 per year, if that helps. So all I have to do is plug in negative 125, and to finish off the problem, I'm guessing, did they simplify it to get v alone? Okay. So simplify to get v alone, and then you're good. Does that make sense why the numbers went where they were? T was an X, V was a Y, dollars per year was an M. And this is actually a huge idea that we're going to definitely develop more this year. But rate, rate always has to do or corresponds with slope. But anyway, miles per hour, feet per second, dollars per year, pounds per month. Rate always has to do with slope. All right, cool kids. With that, I think we have the rest of our questions totally answered. So let's go ahead and clear off this homework. Let's get back to section 1.4 because we do have to get a good start in that. However, I did tell you guys I was going to talk about this white sheet that you had, right? Okay. I have everybody's quiz graded except for Salma. I'm so sorry. I forgot your quiz here over the weekend. So at lunchtime, if you want to drop by, I'll give it to you. Okay. She made hers up on Friday. So that's why you guys get to get yours back. Score is out of, or I give it back to you, because as soon as you get this, what are you all going to be distracted by? Right? Okay. So pause. Let's talk about this right now before I hand it back. Pretty self-explanatory. Name, period, group, score. Go back and forth between what I want in the score. What I want in the score is your current old score before you did corrections. Does that make sense? So then you just give it to me like out of, usually it's out of 100, so you're just going to give me like a percentage, like a 95, an 82, a 64, etc. But when it is out of like a different point, you can find the percentage if you want. You guys know how to do that from fractions, right? How do you find a percentage? Numerator divided by denominator, exactly. So you can write down the percentage if you want, or you can just give me like the 15 out of 20 or the 18 out of 20 or whatever your score is. That's okay too. This is going to be chapter circle quiz. Yeah, circle quiz, and you can just cross that out and write calculator. It's the calculator quiz. It's awkward. The rest of the year you'll be fine on that. It'll be chapter 1A, chapter 1B, chapter 10, chapter 9. This one's weird. It's chapter nothing. Chapter 0? Sure. Like patient 0. You guys see 4 different columns, right? Let me give you a quick example. What if you were to miss, we could just say the first one. Let's say you were to miss number 1. Okay? That doesn't mean necessarily that you missed all of number 1. That just means that you missed some part of it, because anywhere you miss points, whether it's partial credit or full, every problem was worth 2 points. I should say every part to every problem was worth 2 points. That's a better way of putting it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, every part to every problem was worth 2 points. So anywhere you miss points, you're going to want to put that number down because it's required for you to do corrections. The missed concept on number 1 would be the zeros of a function. That was the point. Okay, the zeros of the function was what you were supposed to be using. At the very top, you already said calculator, so don't talk about the calculator. 1 or 2 words is enough. If you miss number 2, it'd be intersection. If you miss number 3, it'd be max min. Number 4 could be a scatter plot, could be a linear regression, or number 5 could be using a regression. Okay, so mixed concepts, super short, super sweet, super to the point. Corrected work. Now, what if you just didn't use your calculator right? Let's say on number 1 you made one of the common mistakes. One of the common mistakes was maybe finding the zeros of h of x even though I didn't ask for it. So maybe it's something where your explanation is like you found the zeros of h of x instead of, maybe that would, I don't know which one you would have replaced it with. Most people figured out the f of x, maybe g of x. So I put that backwards. Probably the higher probability is that you didn't do g. But how could you show me work? Anybody have any ideas? You could write down the steps like the actual buttons you're supposed to choose, but if you just did the wrong function and you know what you're doing, couldn't you maybe just throw in, let's see if it was g, absolute value, shifted right 5 and down 1? Couldn't you just sketch me the graph a little bit and then like actually show me the points and why they are what they are? Does that make sense? So you could, if you miss the calculator buttons, you might want to explain that to me, like hopefully find out how to use the calculator buttons correctly. Maybe you didn't go your left bound far enough, your right bound far enough. You forgot to hit enter on the guess button. Some of you, your decimals were way off. I don't know why. Some of you, your rounding was off. Oh, I stink. Okay, if your rounding is off, how can you show me work on not rounding correctly? What if you did something like the zeros for f of x? The zeros were, and this one is correct, but the other one wasn't. It was supposed to be an 8 and you put a 7. Couldn't you put some more decimals and couldn't you circle and say, oh, he was supposed to round up? Like, couldn't you show me that? Does that make sense? So you don't always have to do a sketch. You don't always have to show work the exact same way another person showed work. Maybe you have different work to show. A lot of people on the minimum put 3.999 instead of 4.000, because if you have 3.999, oh, shouldn't that have rounded up? Struggle. So it might have been a little thing as far as like only losing a little bit of points. However, that is still a correction that needs to be done. So you guys are going to have tonight technically and tomorrow to work on these corrections. You can come in usually during lunch. I think I have a student council meeting today or tomorrow. You can still pop by though, or period 7 or after school to ask. Or tomorrow, first thing, I might give you guys like a minute or two in your groups, if you've already started these, to turn and ask someone else because they did the quiz and maybe they got it right where you got it wrong. You can ask their opinion as well. But I'm giving you guys a couple days so that you don't have to like by yourself figure out everything you did wrong tonight, because that's hard, right? You got it wrong for a reason. So it's going to take a little bit of time to figure out. When you hear your name, come on up and grab it, and then as soon as you do, put your correction paper on top, put it in your hopefully homework spiral folder. And that way it'll make its way home tonight for you to work on. But we're going to go back to notes as soon as these quizzes are done. So Wesley, here you go. Harana, did I say that right? Okay. If I say anything wrong, just let me know. Christopher, Alfredo. I'm sorry, you got stuck to somebody's. There you go. Jordan, Chris Massey. Do you have a sister, Ashley?
Yeah.
Got it. Lauren. Emma, Tyler, Joe Hodgson, Matthew, Samantha, Jason, other Joe. How do you say your last name, Joe? Cal? Zhao. Zhao. Got it. Ariman? Did I say it right? Yeah. Ariman. Okay. Nehemiah? And Priscilla. There you go. All right, cool kids. Put the correction paper on it. Go ahead and store it away. But do not forget about it, because those corrections are due Wednesday in class. Okay? Any questions about the 4 columns and what I mean? This doesn't have to be a huge paragraph, but it should be. Well, hold on. Just for future reference, I think you guys will be okay most of you figuring out what went wrong on the quiz. But sometimes, come on, let's be honest. How many of us have guessed ever on a problem on a test? Okay. So how do you explain what you did wrong? I guessed wrong? No, that wasn't the mistake, right? Every now and then, I get this, I don't know. That's not what I want to hear. So that's why it says explanation of correction or of error. Error is if you tried it and something went wrong, right? Correction is what if it was an I don't know and you guessed. What didn't click in the moment that would have led you to the right answer, or at least you're trying. So if it's ever a problem that you didn't even know how to try and you just totally guessed on, don't just be like, I guessed, I don't know, I don't get anything. Like, I've seen all of them. Instead, right, if you can't tell me what went wrong because you're like, I didn't even know how to start, well, don't tell me that. Tell me what you didn't, oh, I didn't have memorized to find x-intercepts, you set y equal to 0, right? Like you saw x-intercept and you didn't think set y equal to 0, so you didn't know at all what to do. That's a silly example, but it at least gives you the idea. It should never be an I don't know, I guessed, I fail, I'm dumb, I've seen them all. Don't use those as explanations, okay? Just for your own sake and for mine and for everything in between. Hey, course of study, that's not helpful. All right. Thanks, Chris. I got it turned in. Christopher Smith. I got it turned in. Okay. All right, here we are. Chapter 1, section 1.4. I was in Google Classroom and I saw that he submitted it. Here we go. Old school, like Algebra 1 stuff. A relation is any set of ordered pairs relating to quantities. But here's where it gets a little bit tricky. The two quantities part, don't worry. You didn't have to skip a line per se. It'll fit off to the side if you need to. Or just draw a little arrow. But the two quantities, you're going to have to be relating at least two variables, which shouldn't be a big deal. However, in that one we just saw, value and time, a lot of you guys didn't even think about y and x. That value was y and time was t. You were just like, how do I make a line from dollars and years? I don't get it. So they're not always going to say, hey, by the way, y is. Hey, by the way, x is. That's something that we're going to have to learn by doing practice in section 1.4, what's going on. We'll get back to that in just a little bit, but a relation is any set of ordered pairs, any data, nothing special. As long as two variables are related with some sort of numbers in between, we can call it a relation. But a function, you guys have seen it before. What does VLT stand for? Vertical line, vertical line test. Easiest example is your pen or your pencil. Vertical line test, pencil. Where each x has to be paired with one and only one y. So if you were to be given, for instance, some sort of, this is the easiest example, a sideways parabola, right? If you were to take some arbitrary x value, we'll just call him x, wouldn't he go to two different y values? And how does the vertical line test help me with that? It touches in more than one point as I go across, right? And it can happen just once, it can happen multiple times, but if there is any vertical line that would cross through the graph more than once, it would fail being a function. Is this a function? No. But is it a relation? Yeah. So relation is the general term, function is the specific. To be a function, each x has to be paired with one and only one y. I can explain that in a little bit more depth once we get to word problems. For right now, we'll just say it's true. Okay? So looking at these three examples, letter A, you need a little bit of background info, which maybe some of you know and maybe some of you don't. So in the news a lot, Senator John McCain, but that might not help you with letter A. So let's work our way backwards. I think C is the easiest. C is only 1, 2, 3, 4, 5 points. That's it. It's not even supposed to be connected. If we were to actually draw this or write this, it would be one of those weird -1, 0, 0, -1. It's only those 5 points. But if I was to write out all of those 5 points, guys, is there any x value that has more than 1 point that's attached to it?
No.
No. So therefore, is it a function? The answer is most definitely. And how can you tell with your vertical line? Well, it doesn't hit more than 1 point at a time. Horizontal line, that's a whole other thing. That doesn't have to do with functions. There's like an adjective that has to do with. But that's later. How about this table? How can we think about matching x's with y's and whether or not it's a function looking at a table? What do you guys think? Pass or fail? For letter B. Mm-hmm. Because one x value goes to 2 different y's, right? So if I was to graph that, I would have right? Fail. So it is a relation, check, but is it a function? No. So we could say function, it's only a relation. It's only a relation. Okay, how about letter A? This section might be asking you to like draw on knowledge from either other fields or other maths like geometry and shapes and area and stuff. All right, this one's more of a government thing. Anybody know each state? How many representatives or how many senators, how that's determined? Population determines which one? Representatives. Good. So if I was to think about who's who, X's are the representative. This varies based on population, right? So in the United States government, how many representatives for California is very different than how many representatives from like North Dakota or Wyoming, sure. Right? Very different. I just picked one. Right? The population is going to determine how many representatives. So X is going to, now hold on, do you think any states might have the same number of representatives? Possible, if any states have similar populations. Maybe not, but maybe. So no negative numbers, no zeros, unless a poor state no longer has people. But besides that, right, you're going to have all these different numbers of representatives depending on what state you're from. Maybe X could be used more than once. Oh, it's not a function. If X could be used more than once, wait. How are senators determined?
2 per state.
Always 2?
Yeah.
Yes. It's okay if you didn't know that. But 2 per state. So wait a minute. Is any X, even if it's used more than once, is any X going to ever map to a different Y?
Yeah.
There might be an X that's used more than once. Maybe both 2 states have 5 representatives, but is it a problem? No, because the Y's are always going to be 2. So you can sometimes have a repeated X, but if that repeated X goes to the same Y, is it a problem?
No.
No. So therefore, is this a function? And the answer is yes. Super awkward of an example. I totally agree. But it did get the idea across that sometimes the X might be repeated, but if the Y is not different or unique from each other, it's no big deal. All right, so then our last thing for today is going to be, in math, it's kind of called the rule of 4. Like, I don't know, with teachers and credentialing and all this stuff. It's called the rule of 4. But basically, you can see math 4 different ways. Either it can be described to you in words, which I was just going to have you guys go back to the example. It's like the senators representatives one. It can just be the relationship can be described just verbally with words, numerically with tables or ordered pairs, which would be like data points, like statistical studies, etc. Graphs, I mean, that one's easy. Or algebraically with equations. And ironically, even though you guys have known words a lot longer than equations, almost everyone would rather math be given to them in equations. But we'll see how you guys do when we get a little bit further into functions tomorrow. What's my advice for tonight? Start working on quiz corrections. All right. If you guys need anything, come on by, let me know. Otherwise,